So I'm going to show you first of all elimination method. And in my class, I don't care which methods you use, but when you get into Algebra 2, your teachers may say you have to do elimination, or you have to do substitution, or you have to do graphing. So you'll just have to do whatever they're testing you on. But for me, I just want you to be able to solve for x and y. So however is easiest for you works for me. Elimination method, though, is where you want the same variable, same coefficient in front of the same variable. So for example, if I look at y, what would I need to multiply the second equation by to get the same number in front of y? 2. Does everybody agree if I multiply by 2, this would be 4y and this would be 4y? But if I add 4y plus 4y, that gives me 8y. I want them to eliminate. So what do I really want to multiply by? Negative 2. If I multiply this by negative 2, then it'll be negative 4y. And when I add them, they will go away. Hence the name elimination. So I'm going to label my equations, especially when you get to Algebra 2 and you're doing 3 equations. It's easier if you label and you can kind of keep track of your different equations. So I'm going to multiply by negative 2. Don't forget that you multiply every single term. You can't pick and choose what to multiply. So here's my new equation number 2. Negative 2 times 5x will be negative 10x. Negative 2 times 2y will be negative 4y. And negative 2 times 108 will be negative 216. Is that okay? Then I'm going to bring down equation number 1, leaving it the same as it was. 2x plus 4y equals 72. Okay, so which variable am I eliminating? Y. Stop before we do it. Let's go back. What if I had wanted to eliminate x? What would I need to multiply these equations by so that they have the same number in front of x? Okay, I could multiply, if I multiply them both by 5, that's going to give me 10 and 25. Okay, so Caden said multiply the first one by 5 and the second one by 2. And if I do negative 2, then that'll give me a positive 10 and a negative 10. So one of them needs to be multiplied by a negative. You guys see that sometimes you have to multiply both equations, and it may be by different numbers. You get to decide which variable you want to eliminate. I chose y because it was easier. We could just multiply one equation. Is everybody following, though, that we can multiply by 5 and negative 2? Okay, so now we're just going to add straight down. So negative 10 plus 2 is negative 8x. Negative 4y plus 4y eliminates. That's 0. Equals, and what's negative 216 plus 72? Tell me if I'm right. Negative 144? Okay. Divide by negative 8. And what do we get for x? Positive 18. A negative divided by negative is a positive, so we should be getting positive 18. Questions so far? Is this coming back to you? Okay, so now that we know that x is 18, what do we do to find y? Plug it in, substitute it. So we can plug it back into either equation, it doesn't matter. I'm going to go back into equation number 1. Mrs. Lash. Gavin, Sure. Goodbye. Okay, so we're going to plug 18 in. I'm going to choose number 1, but again, it doesn't matter which equation. So number 1 was 2 times x. Our x is now 18 plus 4y equals 72. What's 2 times 18? So 36 plus 4y equals 72. Subtract that 36 to the other side. And we get 4y is equal to 36. And then divide by 4. And y is equal to 9. Now in Algebra 1, you were trying to find the point of intersection for these two lines or this system of equations, and so you actually wrote your answers how? As an ordered pair. 18 comma 9 because it was a point where the two lines intersected. We are just going to be using this in geometry to solve for our variables x and y. We're not really thinking about this graphically as lines, okay? So you can just tell me what the answers for x and y are. Questions on elimination? Okay, I'm going to review substitution as well because elimination isn't always the easiest way to work the problem. So I'll go over substitution method, and then again, if you have questions, come see me. So substitution method. Help me out. What were the equations again? Okay, so thank you. Those are our two equations. So for substitution method, you want to solve one of the equations for one of the variables. So again, I'm going to number my equations so I can refer back to them. If I look at my two equations and I want to solve for a variable, think about which equation might be easier to get by itself, which equation might end up giving you fractions, which one would give you whole numbers, just to try to pick an easier equation to use. So if I try to solve for x on number 2, I'm eventually going to have to divide by 5. And if I divide by 5, I'm going to end up with a fraction, 2/5, right? But if I try to solve for x on the first equation, what do you notice about all of the numbers? They're even, so they're all going to be divisible by 2. So when I divide by 2, I won't end up with fractions. Not that you can't have fractions, it's just fractions sometimes are harder to work with. So I'm going to choose to use number 1, and I'm going to choose to solve for x instead of y so that my numbers are nice, pretty whole numbers. So I'm going to take this equation, 2x plus 4y equals 72, and I'm going to get x by itself. So what's the first thing I need to do? Subtract the 4y. So now I'm going to have 2x equals negative 4y plus 72. It can, but in Algebra 1, your teacher should have tried to always get you to write your equations as y equals mx plus b, trying to get that in slope-intercept form. So I usually always try to keep my variable in front of my number just because that is standard form. Okay, so from here, what do I do? Divide by 2. And remember, every single term gets divided by 2. You can't pick and choose. So x is equal to negative 2y plus 36. So in substitution methods, you're getting x by itself. X is equal to all of this. And then what do we do with all of that? We substitute it. Where do we substitute it? In place of x in which equation? If we go back into the original equation, all it's going to do is cancel everything out. We can't use the same equation we started with. Okay, so we have to substitute all of this in for x into the second equation. Again, that's kind of another reason to number them so you'll recognize you started with number 1, you have to substitute it in to number 2 for x. Is this coming back to you? Slowly? Okay, so we're going to substitute this in. So I'm going to use equation number 2 now. 5 times, plugging in all of this for x, negative 2y plus 36, and then I have plus 2y equals 108. Make sure you're following me. I'm just plugging all of that in for the x here, and then writing the rest of the equation. Are we good? Okay, so all of that went in for this x, and then I bring down this 2y and this 108. Now we're going to do what? Distribute. So we distribute the 5, and we get negative 10y plus 180 plus 2y equals 108. Now we're going to combine like terms. What's negative 10y plus 2y? Negative 8y plus 180 equals 108. Then what do? Subtract the 180. So we have negative 8y equals negative 72. Is that correct? And then what do? Divide by negative 8. And that gives us y is equal to 9. And is that what we had originally when we solved the other way? Yes, we had y was equal to 9. So what do we do once we get that y is equal to 9? At this point, it's the same as before. You just have to substitute it back in somewhere. You can substitute it in anywhere. You could go back up to equation 1, equation 2, or where I prefer to substitute it in is where we had our x equals, because that's what we're trying to find now is x. Does that make sense? So now we're going to substitute this y in for the y over here. So we're going to have x equals -2 times 9 plus 36, which gives us -18 plus 36, which is equal to 18. And is that what we had for x? Yes. Okay, raise your hand if now you feel like you understand how to do substitution or elimination. Okay, if you don't, again, I'm not saying I won't help you. I'm just saying I can't take more class time. So please come in, let me sit down with you. I can give you some practice problems to try and encore. We can check your answers, that kind of stuff. But you need to know how to do it one way or the other. I'm not testing you on both methods. Any questions? Okay, save that bell work, because then you can look back at it if you need to refresh your memory. So now we are starting our chapter 3, section 2. I will tell you that in the pre-AP class before this, we did not finish everything today. We're going to get as far as we possibly can, but there's a lot of information to go over. The good and bad thing is tomorrow we have really short classes, so the 8A class is going to get really behind you guys. But then next week, you guys will be taking tests on Wednesday, depending on your grade level. Has anybody talked to you about that yet? So some of you will be taking PSAT if you are a sophomore or you signed up as a junior. Some of you will be taking the ACT interim if you are freshmen and did not sign up to take the PSAT. And juniors will be taking the ASVAB. So Wednesday will be a weird day next week where we're like not going to normal class in the mornings. After lunch, we'll have class periods. And so the plan there is that Wednesday we'll get caught back up in the other class, and so then everybody will be on the same track. That's my plan. We'll see how that all works out. I like to plan a lot, and then reality hits, and it doesn't always work out. We'll see. Okay, so what is super important today, besides being able to solve a system, is, I think I'm passing back too many, is you need to know the difference between the 5 angle pairs that you did the homework on that you just turned in, because we are using that significantly today. Yeah, I laid one here, and then I just passed them back to Chelsea. Test, by the way, we probably won't look at that today because we have too much to do. However, if you are dying to look at your test, you can always come in or stick around for a minute and see your test. They are graded. They're in the computer. They're sitting right here, but we just aren't going to have time today. I'm going to wait till next week because I want to spend some time going over it. So, yeah. So, we won't do that today. Okay. Okay, so I'm going to give you just kind of a big overview today. 3-2. 3-2 is going to say, take those 5 angle pairs we talked about last class period, corresponding alternate interior, alternate exterior, same side interior, and same side exterior. And today we're going to learn 5 theorems or postulates that start out with a conditional statement if the lines are parallel. And you may want to write this down somewhere on your notes. I don't know if you have room, but over to the side or on a separate sheet of paper, wherever you have room. But this is the big idea in section 3-2. If the lines are parallel, then we're going to get to conclude some information today. We're going to get to conclude that either those angle pairs are going to be congruent or those angle pairs are going to be supplementary. What I'm going to do is have you start with one postulate that we're just going to believe to be true, and then we're going to discover the other four theorems together, okay? So we're going to start with the very first postulate, which is going to be the corresponding angles postulate. So if you look at your notes, that's this postulate here. And again, it starts out with, and I'm going to make a huge deal about this today, if the lines are what? Parallel. Everything we're going to learn today would not be true if the lines are not parallel. So the very first thing you're going to do is you're going to look at the picture and you're going to ask, did they mark the lines parallel? If they're not parallel, then you cannot use what we're learning today. If the lines are parallel, then the corresponding angles postulate says, if two parallel lines are cut by a transversal, then the corresponding angles will be congruent. So we're going to say that if lines are parallel, then the corresponding angles will be congruent. That's our very first postulate. And again, we're going to call it a postulate because postulates are things that we believe to be true, but we didn't prove them true. So we're going to believe this to be true today, and then everything else we learn is going to be a theorem because we're going to develop it or discover it and prove it. So on my board up here, I'm going to go ahead and pick some corresponding angles here. I'm going to start with angle 1 and say that angle 1 is 100 degrees. So what is corresponding to angle 1? Angle 3. So what's the measure of angle 3 going to be? 100 degrees. Okay, so we agree today, corresponding angles postulate says if the lines are parallel, the corresponding angles are congruent. Now I want you to think back to some angles that have nothing to do with lines being parallel that we learned last chapter that are also congruent, but they don't have anything to do with lines being parallel. So I'm going to draw a little line here. This has nothing to do with the lines being parallel. What kind of angles are 1 and 6? 1 and 6. 1 and 6 has nothing to do with chapter 3. What are 1 and 6? I heard somebody say it. Vertical angles. Everybody remember when two lines intersect, the angles that are across from each other are vertical. Yes, I heard you say it earlier. So what do we know about vertical angles? They're what? They're the same or congruent. What tells me that they're congruent? The vertical angle theorem. So on your paper, you need to add that another kind of angles that will be congruent are your vertical angles. And the reason you know that is by the vertical angle theorem. That's a huge, very important theorem. You have got to memorize that one. We're going to use it over and over again. Vertical angle theorem says that vertical angles are congruent. So when I look at the picture, I should know from chapter 1, not chapter 3, that 1 and 6 are congruent. So what's the measure of angle 6? 100 degrees. Okay? I'm going to keep using what we've learned today. So what kind of angles are 6 and 8? Corresponding. So what should the measure of angle 8 be, learning the corresponding angles postulate? 100, because they should be congruent. Are you guys following me? So we just learned that corresponding angles are congruent, and we already knew that vertical angles are congruent. Okay? So now let's think back to something we learned back in chapter 1 again. It has nothing to do with lines being parallel. What kind of angles are 1 and 2? Okay? They are a linear pair. Linear pair. Again, this has nothing to do with the lines being parallel, so I'm going to draw a little line here. But the linear pairs, what do we know about their measures? Okay, I heard somebody say it that they're supplementary, which means they add to be 180. So they are supplementary, has nothing to do with the lines being parallel. Let's add them down here. Linear pairs are always going to be supplementary. What tells me that? Linear pair what? Linear pair theorem. Miss Lashley. It's okay. Yes, okay, I'll send him things. Bye-bye. Dusty. Miss Grace. Miss Grace. Okay, so I heard you guys say it. Linear pair theorem. Okay, so these are things that you have to memorize. So if you don't have them memorized, write them down. This is a great little chart for you to use. We know that the linear pairs are going to be supplementary. So if that's the case, and 1 and 2 are a linear pair, what's the measure of angle 2 going to have to be? 80 degrees, because it needs to add to the 100 to be 180. Okay, let's go back to the vertical angles. What angle is vertical to angle 2? 5. So what does 5 have to be? 80. What's corresponding to 5? 7. So what does 7 have to be? 80. And what's vertical to 7? 4. So 4 has to be 80. Okay, so now we know what every angle is in this picture, and we're going to be able to make some conclusions about other angles in this picture that are either congruent or supplementary. So we learned about corresponding angles, and we already said that the postulate says those are congruent. So look at the picture. What do you notice about the alternate interior angles? They're congruent. Which angles are alternate interior? 2 and 7 and 3 and 6. And would you agree that 2 and 7 are both 80 and 3 and 6 are both 100? So we can add up here then that if the lines are parallel, only if the lines are parallel, alternate interior angles will always be congruent. This is always true if the lines are parallel. Okay, now look for your alternate exterior angles. Which angles are alternate exterior? 1 and 8 or 4 and 5. What do you notice about them? They're also congruent. So if the lines are parallel, the alternate exterior angles will also be congruent. Are we good so far? Okay, moving on. The other kind of angles that we talked about last class period were same side angles. We had same side interior and same side exterior. Let's start with same side interior. Which angles are same side interior? Okay, 6 and 7. And what do you notice about the sum of 6 and 7? It's 180, which makes it supplementary. And the same would go for the ones up above, 2 and 3. So the first pair of angles that are supplementary are going to be the same side interior. And again, if the lines are parallel, those will always be supplementary. They will always add to be 180. Okay, look at same side exterior. Which angles are same side exterior? 5 and 8 or 1 and 4. So if I look at 1 and 4, what do you notice about their sum? They equal 180, 5 and 8, supplementary. So we can say that same side exterior angles are supplementary. Now we didn't write a formal proof, but we did get that by using one angle measure, starting with the corresponding angles postulate. We were able to prove that all of these things are true. Would you guys agree? Okay, so the next thing you're going to see in your notes, I'm going to skip this for a second. Go to this slide. This is really small and really blurry on your paper. This is in your book. So if you are looking at that going, oh my goodness, I cannot even read that. It's in your book. So turn to section 3.2 later when you're trying to go through your notes and you can't read this, and just know it's in your book. You can pull it up in there in section 3.2. But basically what it says is what we wrote on the board. That if you have alternate interior angles, alternate interior angle theorem, it's a theorem because we're proving it true. It says if two parallel lines, because again, that's the foundation today, is the lines have to be parallel, then the alternate interior angles will be congruent. Alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. Same side interior angles theorem. If two parallel lines are cut by a transversal, same side interior angles are supplementary. And then the one that they always skip in the book, and you may want to add, is the same side exterior angles theorem. And it says basically the exact same thing as the same side interior angles theorem. That if two parallel lines are cut by a transversal, then the same side exterior angles will now be supplementary. Questions so far? Okay, vertical angles have nothing to do with the lines being parallel. Vertical angles are always congruent. Linear pairs have nothing to do with lines being parallel, but they're always supplementary. So the rest of the notes are going to be some examples where they want you to figure out what the measures of angles are. And just like we did back here at the very beginning, I would start with an angle measure and fill in all the rest of the angle measures. And then it'll be really easy to answer the questions from there. Before we look at an example, this is important. It says if a transversal is perpendicular to two parallel lines. So parallel line, parallel line. If the transversal is perpendicular to these parallel lines, what's it mean to be perpendicular? What happens when two lines are perpendicular? Okay, they meet at a 90-degree angle or they intersect to form a right angle. So it says if the transversal is perpendicular to the two parallel lines, then all 8 angles are going to be what? 90 degrees, because they're all going to be right angles. So make sure that makes sense to you, because that's important. And then this is just reminding you one more time that this first one we started with today is going to be called a postulate because we accepted it as true. But the rest of these are going to be what? Theorems, because we proved them true. And we could write a formal proof for them if we wanted to in 2 columns. But we're just going to use our numbers to deduce that today to make it easy. Okay? So we're going to do a couple together, and then I'm going to have you guys try some on your own. So we're going to start here with this one. It says find each angle measure. So again, the very first thing you have to look for in your picture that we started out with today is, are the lines parallel? If they are not parallel, nothing we just learned is true. So do you see 2 lines that are parallel in this picture? Yes. You're looking for those arrows. So that means that this line is parallel to this line. Okay? The next thing I would do to make your life easy, because you can make this problem hard or you can make it easy, is I would find the angle measure that they've given you, and I would find every angle really quickly. And then you can answer the questions. So if this angle is 70, what do I know about this angle here? Because they're what kind of angles? Vertical. If this angle is 70, what do I know about this angle here? It's 70. What kind of angles are these 2 angles? Corresponding. If this angle is 70, what about this one here? It's 70 because it's what kind of angle? These 2 right here? These 2 are vertical, guys. They are just made by 2 lines. If it's just 2 lines, then they have nothing to do with the lines being parallel. These 2 intersecting lines are across from each other. Those are vertical angles. Okay? So now, what about the angles that are missing in the picture? What do we know about these 2 angles? They're a linear pair. So therefore, what does this angle have to be? 110. And its vertical angle over here would be 110. What about this angle that it's corresponding to over here? 110. And its vertical angle, 110. And now we should easily be able to answer those questions. So what's the measure of angle ECF in the picture? 70 degrees. What about DCE? 110. Did we have to use those variable expressions, 4x plus 22 or 5x at all? No. Sometimes you're going to have to, but in this case, if they gave us an angle measure, we don't even need those. They might ask you to find x. If they did, then we could work it one of two ways. We could say 5x equals 110, or we could say 4x plus 22 equals 110, and solve for x. On the homework, some of the questions are going to ask you to name the theorem that you used. You are all going to look at this differently. So for example, if I started with this problem, and everybody look up here with me for just 1 minute, ECF, if that was the first problem I started with, you might look at this being 70 and this one and say, oh, these angles are what kind of angles again? Corresponding. So you might say 70 degrees by the corresponding angles postulate. But your friend might look at it and say, oh, well, if this one's 70, then the alternate interior angle has to be 70, and then this one's vertical, so it has to be 70. Do you see that? So your friend might have alternate interior angle theorem and vertical angle theorem, and you would both be right. So when you're trying to check the reasoning in the back of the book, it's not necessarily going to be the same as your reasoning, because you can look at it lots of different ways. Did it ask us to explain our reasoning? No. So if it doesn't, you can just put 70 and 110. Okay. Any questions? There should be 4 on the back, right? Okay, I want you to try the next 3, leaving the last one, and we'll work it together. The next 3, but hold on, let's make sure you understand where things are located because your pictures are smaller. So x degrees is referring to this angle, 118 is referring to this angle. Everybody good with that? Okay, I'm going to skip this real fast. All right, and then this one, 75 is this angle, 2x minus 135 is this angle, x is this angle, x minus 30 is this angle. Everybody good with that? Okay, it's the last one there, or the next one there that I think is a little bit harder. This one is pointing to this angle. This one is pointing to this angle. Okay, I'm going to give you a few minutes to work. So I'm going to go back here. Remember, you're asking yourself every time, what kind of angles do I have? They're going to be one of two things. They're either going to be in this column so that they're equal or congruent, or they're going to be in this column where they add to be 180 or supplementary. Okay? So every time you're asking yourself, what kind of angles do I have? So when you look at this picture, what kind of angles are these? Corresponding. And corresponding angles are congruent. So that means this angle is 118. But it asked for QRS. QRS is not this angle. QRS is the angle adjacent to X. So what kind of angles are these two angles? Okay, when I ask you what kind, I don't want to hear congruent or supplementary. I want you to tell me what kind of angle pair they are. So what kind of angles are these two? These two are not alternate interior. Linear pair. They have nothing to do with this line. They have nothing to do with parallel lines. They're just two angles formed by two intersecting lines. That's a linear pair. If they're a linear pair, they are what? Equal to supplementary. They add equal 180. So what is this angle going to be? 62 degrees. So the answer here should have been 62 degrees. Now, I want to warn you, on the homework, sometimes it's going to ask you to name what theorems you used. So you have to think about what kind of angles to know which theorem to write down. So I used 2 theorems just now, corresponding angles postulate and linear pair theorem. So watch your directions. If it says explain, you have to list the theorems that you're using. Does that make sense? This one didn't, so I don't have to do that. Okay, moving on. Next problem. They wanted you to find EDG and BDG. You could have made this hard by finding X, but it didn't ask you to find X. So you could have made it really easy. You could have started with 75 and found every angle measure and then quickly answered these questions. EDG is this angle down here. What kind of angles are this angle and 75? Alternate exterior. And so since the lines are parallel, which they did mark, I just marked over it here and here. Since the lines are parallel, alternate exterior angles are congruent. So right now you can say this is 75 degrees. Okay, and I use the alternate exterior angle theorem. Then they wanted you to find BDG. So BDG is this angle. I know right now that this one is 75. What kind of angles are these two angles? Good, linear pair. And if they're a linear pair, they are what? Supplementary. So that means angle X has to be how much? 105. And if I were writing down my reason, I would have used alternate exterior for part A and then linear pair theorem for part B. Is this making sense? Okay. Slowly but surely. Okay, this one is one I had to walk around and help a little bit more with, this next one. So again, you're looking at the picture and asking yourself, what kind of angles do I have? So what kind of angles are these two angles? Alternate interior. And we know that if the lines are parallel, then those angles are congruent. And congruent means they're equal. So we should say 2x plus 10 equals 3x minus 15. Okay, so you're either going to be setting them equal or adding them and setting them equal to 180. And you've got to recognize when to do which. Are you good, Jaden? Okay, feels good to be right. Okay, so from here, we're going to subtract 2x. 10 equals, I don't know why my board keeps messing up right here. 10 equals x minus 15. Then we'll do what? Add 15. So what do we get for x? X equals 25. Is that my answer? No, but watch, because sometimes, questions? Okay. Sometimes the book's just going to ask you to solve for x. And so if they do, you're done. But if they don't, read your directions. It says find A, B, D. So we go back up here. A, B, D is talking about this angle, which was 2x plus 10. So we have to substitute that in. What is 2 times 25 plus 10? 60 degrees. So this angle is 60 degrees. Yes, sir. Okay, so you use the fact that they were supplementary, but alternate interior angles are not supplementary, they're congruent. So that's where you first have to ask yourself, Jaden, what kind of angles are they? Then that determines whether you set them equal or you add them and set them equal to 180. If they had been same side interior or exterior, you would have added them and set them equal to 180. Okay? All right, any questions up to here? Okay, last example, I saw some of you already working ahead, so great job for some of you who came to here. But this one wants us to find what? X and Y. So first of all, I'm going to warn you one more time. Today's lesson is based on the fact that the lines have to be what? Parallel. So when you look at this picture, which lines are marked parallel? Okay? Which lines are not marked parallel? P and Q. Therefore, you cannot look at these two lines and say that these two angles right here are corresponding, which they are, but you cannot say that these two angles are congruent, because they're only congruent if the lines are parallel. They are corresponding, but they're not congruent unless the lines are parallel. So you cannot set those equal to each other. Okay? So let's look at the lines that are parallel. starting with these two lines and this transversal. And when these pictures get a little crazy like this, you're going to have to try to pick out just part of it. So these two lines and this transversal. Look at this angle and the other angle that's in that picture. They're pointing to this angle right here. So what kind of angles are these two angles? Corresponding. They're on the same side, but they're not both interior or both exterior. So they're called corresponding. Corresponding angles, because the lines are parallel, are congruent. So we can say 5x plus 5y is what? Equal to 60. So 5x plus 5y equals 60. Today we started with bell work. And in our bell work, we had equations that had two variables. When you have two variables, how many equations do you have to solve it? Two. When you get to algebra 2, you're going to have equations with three variables. How many equations are you going to have to solve for three variables? Three. Okay, so it just builds, but it's the same process. So we're going to write this equation, and we're going to look for a second equation. So go to your picture, and let's see what else we can find. We've got this angle pointing right here that's made with this line. And then we have this other angle over here that's made by this line. And what transversal do they use? P. So again, sometimes it helps to highlight or color in just what you're looking at. So I'm pointing to this angle right here and this angle right here. What kind of angles are those? Alternate interior. And what do we know about alternate interior angles? They're congruent if the lines are parallel, which these are. So now we can say 5x plus 4y equals 55. And then you get to choose, would you prefer elimination or substitution to solve? What do you think is going to be easier here? I would agree, elimination. Which variable do you want to eliminate? X. It's already got a 5 in front of both. So what do we only need to do? Multiply one of them by a -1. I'm going to multiply the top one by a -1. So I'm going to come down here and rewrite equation 1 after I multiply every single term by -1. So now I'm going to get -5x minus 5y. And again, my board won't write very well right here for some reason. Now, equals -60. So I'm just multiplying equation number 1 by -1, and then I brought it back down. So now I'm going to look at these two equations underneath here. And I'm going to add them together, number 2 and number 1. What's 5x minus 5x? 0, that you eliminate. 4 minus 5y, -1y, equals 55 minus 60, -5. So what's the last thing we need to do? Divide by -1, and y is equal to 5. It said find x and y. Once we find y, what do? Plug it in. And does it matter which equation? No. I'm going to go back up to the first one that we had to start with, the one in blue, but it doesn't matter. So back up here to equation number 1, 5x plus 5. Now I'm going to plug in this 5 for y equals 60. That gives me 5x plus 25 equals 60. What do I do from there? Subtract the 25. And 5x is equal to 35. And lastly, divide by 5, and what is x? 7. And again, we're just solving for x and y for our geometry problem. You don't have to write these as ordered pairs. You're not solving a system of lines. Questions on 3-2? No questions? Feel good? Okay, every time you have to ask yourself, what kind of angles? Are they equal or are they supplementary? But what has to be true first? The lines have to be parallel. Okay, we're going to look at 3-2, or 3-3, I mean. Okay, I know this is a lot today. Bear with me. 3.3 is really not anything new. What we're going to do in 3.3 is what we learned in chapter 2. 3.3 is all about converses. Remind me, what does a converse do to an if-then statement? Okay, so you switch the hypothesis and the conclusion, right? Okay, so here's what 3.2 said. If the lines are parallel, then these angles are congruent and these angles are supplementary, right? Are you with me? Okay, so we're going to switch those and we're going to say if these angles are congruent and these angles are supplementary, then the lines are parallel. So 3.3 is going to ask you, are the lines parallel? And you're going to have to base that off of checking to see, are the right kind of angles marked congruent or are the right kind of angles marked supplementary? Sorry, Mrs. Ashley. So sorry. Thank you. Bye-bye. That time's my fault. Are you nervous they were calling for somebody else to the office? I should have said that. I should have sent one of you. Okay. I thought I put it in. Maybe I didn't save it. No, I didn't. Okay. Okay, focus back. Here we go. So now, if you did this over here on your notes somewhere, I want you to make another place on your notes and write this down. If. So now we're switching. If these angles are congruent or these angles are supplementary. And it doesn't have to all be true, just one of them needs to be true. So if the corresponding angles are congruent, or if the alternate interior angles are congruent, or if the alternate exterior angles are congruent, or if the same side interior angles are supplementary, or if the same side exterior angles are supplementary. If these things are true, then what can we say today? The lines are parallel. So we are using what? Is this called when we switch it? Converses. So all of these are going to be called converses. So instead of it being called the corresponding angles postulate, it's going to be called the converse of the corresponding angles postulate. Instead of it being the same side exterior angle theorem, it's going to be the converse of the same side exterior angle theorem. These are going to be long names that you're going to have to know. Okay, but they are not hard. They're the name of the angle pair. Okay, don't make it harder than it is. So I'm going to start with this very first one in your notes. If you look at your notes with me. Are we caught up? Did I go too fast getting that on the board? Okay. All right, so first theorem in your notes here. Notice that the lines are not marked what? They're not marked parallel. This says if you just have two coplanar lines, they do not have to be marked parallel. But if you have two lines cut by a transversal so that the corresponding angles are congruent. When you look at the picture, do you see that the corresponding angles are marked congruent? If the corresponding angles are marked congruent or listed congruent, then you get to conclude that the lines are parallel. So in a proof, if you are trying to say M is parallel to N, your reason is going to be the converse of one of our 5 postulates or theorems today, depending on which angle pair you're looking at. If they're corresponding, it'll be the converse of the corresponding angles postulate. If you're looking at alternate exterior angles marked congruent, it'll be the converse of the alternate exterior angle theorem. So when are we using converses? When we're trying to prove lines are parallel. When your statement is about lines being parallel, you're using the converse. If they tell you the lines are parallel, then you're using the original theorem to decide what's true about the angles. Are you with me? Because the biggest mistake you'll make on the test is not putting converse when you should or putting converse when you shouldn't. So converse is only if your conclusion is the lines are parallel. No converse if your conclusion is the angles are congruent or supplementary. Jaden? Okay. I'll keep going and see if it helps answer it, and if not, ask me. Okay, so look at the next slides. Again, this is hard to read in your notes. This is in your book. So if you look at this and you're like, holy cow, lady, I cannot read that. I promise you it's nice and pretty colored in your book. Okay? But here's what it says one more time. These same theorems, but they all start with converse of, converse of, converse of. Because the conclusion is the lines are parallel, the lines are parallel, the lines are parallel. Are you with me that converses prove lines parallel? Okay, I'm trying to say it a lot so it sticks. So again, are the lines marked parallel? No, but notice that you have what kind of angles here? Alternate interior, and they're marked congruent, and so if they're congruent, then we can say that the lines are parallel, and that's the converse of the alternate interior angle theorem. Same thing here, what kind of angles do we have? Alternate exterior, and they're marked congruent, so the lines have to be parallel. Converse of alternate exterior angles theorem. This one's a little different. What kind of angles are 5 and 6? Same side interior, and they don't mark them congruent. They tell you that they add to be 180, which means they are supplementary. And so if the same side are supplementary, then the lines are parallel. And it's still converse of the same side interior angle theorem. And then as usual, the one they forget, you can add here in your notes, is the converse of same side, and it's going to keep erasing, exterior angle theorem. So write what I'm saying, not what you see. And it's going to say the same thing as this one. But if the lines are angles are supplementary, then the lines are parallel. Are we clear? Okay, so 3.3 is not going to ask you to find angle measures. They're going to ask you, is there information enough to prove these lines are parallel? So let's look at some examples. And again, we won't finish all of these. We're going to get as far as we can. I want to show you some proofs, though, because 3.3 is going to be about proofs. They won't be hard if you take good notes. They will be hard if you don't. You need to write these examples down, because then the homework is just like the examples, I promise, okay? If the homework says to show, I want you to write a 2-column proof. The book may not. I am telling you that that's how I am grading it. You have to write a 2-column proof. So they're going to give you a picture. They're going to give you some information. What information are they giving me here? Okay, this is what they're giving me. So what we're going to do is we're going to make a 2-column proof. Again, this is probably going to erase half of what I write, so stay with me. Left side should be labeled statements. Right side should be reasons. And our very first statement is going to be what? Angle 4 is congruent to angle 8. And our very first reason is given. When you look at the picture, I want you to mark your picture. 4 is congruent to 8. What kind of angles are 4 and 8? Corresponding. And we just learned if corresponding angles are congruent, then the lines are parallel. So that's what they want us to show. They want us to show that L is parallel to M. So number 2 will simply be L is parallel. Just kidding, let's write it down. L is parallel to M. Katie? So, good question. You're going to have to, when the problems get harder, at this point, I'm going to leave it up to you. Most geometry teachers are going to say you have to draw the picture and write your proof, but I'm going to leave it up to you. If your pencil goes to the book to mark on it, you need to draw the picture. If you don't need to mark on it, then you don't have to draw the picture. But as the pictures get harder, as we move throughout this year, you're going to have to start drawing your pictures for your proofs because there will be no way to work it without marking on the picture. Okay. Okay. What's going to be my reason for number 2? Exactly. Converse of, because we're proving lines parallel, the corresponding angles, and it was the only one today that was a postulate because we accepted it as true when we started the lesson. All the rest we proved. So converse of the corresponding angles postulate. And that's as hard as that is if it's just a simple one like this. Any questions about this one? Okay, I want to do one more proof, and then we'll stop for today. And that's this one here. And because the board is being so finicky, I'm going to write this on the board. So if you're watching the video, you can look at the filled-in version of the notes. Okay? All right, so first thing we're going to do is read our directions. We are going to use this given information, and we want to show that the lines are parallel. And when we see show, we're going to think, do what? 2-column proof. All right. Because we want to get prepared for the harder ones. And so these are going to be easier, and we're going to set them up while they're easy to get ready for the harder ones. And the very first thing we're going to write down is all of the given. And if you'll notice on this one, we've got a lot of given, right? So let's write it all down. Measure of angle 3 equals 4x minus 80. Measure of angle 7 equals 3x minus 50. And x equals 30. All of that is given. And again, this one is going to be a little bit longer, so I would highly encourage you to write this down so you have it to look back at on the homework, because it's going to be super similar when you're working some of the problems on the homework. Okay, then I would mark my picture. So again, I would draw my picture on the homework so that I can mark on it. We're looking at 3 and 7. So what kind of angles are 3 and 7? Corresponding. And we're trying to prove that the lines are parallel. So what do we need to be true about the corresponding angles for the lines to be parallel? We need them to be congruent, right? You with me there? So that's what we have to show in our proof, is we have to show that they're congruent. So what do you think we might need to do first to try to show that eventually they're going to be congruent? Okay, I heard somebody say plug in the 30 for x. What do we call that when we plug something in? Substitution. So I'm going to go ahead and write my reason down. Substitution. What else do we say? Property of equality. Okay, so now I'm going to substitute it in. Measure of angle 3 equals 4 times 30 minus 80. And then measure of angle 7 equals 3 times 30 minus 50. I'm going to go ahead and substitute it in all at the same time. Is that okay? Just making sure I'm not going too fast. What would we need to do from here? Am I multiplying both sides of the equation? No. What do we call it? Am I distributing? Is there a plus or minus sign that I'm actually distributing into the parentheses? Simplifying. I'm simply working on this right side, and I'm going to multiply and subtract, but I'm only doing it to one side, so we call that simplify. It's only multiplication or subtraction if you're doing it to both sides of the equation. So starting with this first equation, measure angle 3 equals, what's 4 times 30? 120 minus 80, 40. So measure of angle 3 is 40 degrees. We can simplify that all at once. Then go to measure of angle 7. 3 times 30 is 90 minus 50, 40. Now remember, our goal is to prove that these two angles are what? Congruent. We don't have that yet. So now what do we know about angle 3 and angle 7 if they both equal 40? We can't go straight to congruent. We can say they're equal. So we can say measure of angle 3 equals measure of angle 7. What did we use to get that? It's not a definition. Who said that? Very good, Katie. Notice that this is 40 on the right. This is 40 on the right. Both equations are equal to 40. We're getting rid of the 40s and combining the other two parts. We're taking these two equations and combining them to get a third equation, and that is the transitive property of what? Equality. Now, if they're equal, then they're congruent. Very good. Angle 3 is congruent to angle 7, and that is the definition of congruence. And we said that if the angles are congruent, then we could say the lines are parallel. And so what are our two lines that we want to prove parallel? So L is parallel to M. What's going to be the reason? Converse of, and then what kind of angles were 3 and 7? Corresponding. So that's how you know what the name is. It's converse because you're proving the lines parallel. So converse of, and then the angles were corresponding angles, and it's a postulate because it's the first one we accepted as true. Okay, now here's what I need to warn you about. There are several more proofs we haven't done. We did not work one where we had to prove that the two angles were supplementary. So when you get to the homework, I'm not going to collect the homework on Monday. However, Monday you're going to have more homework. And that means that Monday you're going to have 2 assignments that are going to be due when? Wednesday. So what you don't want to do is go, oh, this isn't due till Wednesday, and wait till Monday, because then you're going to be really overwhelmed. Okay? So, did we do all of 3-2? All of 3-2? Yes. So you should be able to do all of textbook page 185. We did a couple proofs where it was proving that angles were congruent to get the lines parallel. So if it's a proof that has to deal with one of these 3 kinds of angles, you can probably do those. If it's something about them being supplementary, I would wait until we have class on Monday, okay? All right. Right at the top of this, do Wednesday.